Hello, this is Robert, and in this video I would like to discuss circular linked lists. And I've created a graphic here to show the difference between a standard linked list, or how we might set one up, and a circular linked list. So in a standard linked list, if we create an abstract data type using a class, typically in the constructor we would set the head pointer equal to null pointer to signify that we had an empty list. So in the constructor, we would say head equals null pointer. And that's signified right there with a slash through the memory location. And then when we add nodes to a standard linked list, and in this example, I'm adding nodes to the front. So 7 was the first node to be added, and then 5, and then 3. In a standard linked list, the tail node, the last node in the linked list, has a next or link member that is set to null. And so when we're traversing a linked list like this, we know we're at the end of the linked list when the next or link member is set to null pointer. In a circular linked list, by contrast, we have an empty linked list when we have one node in the linked list. So this is what's called a dummy head node. And notice that with an empty list like this, the head is not set to null pointer. So in the constructor for a circular linked list, we would set up the head to point to a dummy node, and then we set head next, which is this member right there, to point back to head. And so if we take a look at this particular graphic, there are no null pointers here. So head is not set to null pointer, and then the next field is also not set to null pointer. And that's the goal of a circular linked list, is not to have any pointers that are set to null or null pointer. So in the previous example with a standard linked list, we had a null pointer for our head, and then we have a next pointer right there that's also set to null pointer. If we add a node to a circular linked list, it's added after the dummy head. So this is still adding to the front of the linked list. It's just that we have to add every node after the dummy head. So I've built the circular linked list by adding nodes to the front, and so here's a circular linked list that has 3 nodes. 7 was added first, and then 5, and then 3 was added last. And they all were added after the dummy head. So let's take a look at the code to add the first node to the circular linked list. If we create a temporary pointer, we can use that temporary node pointer to create a new node, and then we would set the number value right there, and then so temp next equals head next. With the empty list, head was pointing to itself, so now temp is pointing to the dummy head node. Temp next equals head next right there. Head next was pointing to head, so now temp next is pointing to head right there. And then we say head next equals temp. So that makes 7 the first node in the linked list. And then plus we have the dummy head right there. Okay, we can repeat this process as many times as we want to add as many nodes to the front of a circular linked list as we want. So I've done it 3 times here to add 3 nodes. And the last node points back to the dummy head right there. Some coders feel that this is a waste of space, and depending on the size of your class or node, it could be a waste of space. And so what they'll do instead is they'll create a kind of like a mixture of a regular linked list, where they'll actually set the head pointer equal to null pointer, and then they'll wait to set the next pointer for the first node once it's created. So the goal of a circular linked list is not to have any pointers set to null pointer. But if you want to save a little space, you can make one exception and you can set head equal to null pointer. And then wait. And then when you create the head node, you can actually put data in there. And then you can say head next equals head. And then you'll have a circular link that way. And you won't have to waste the space for the dummy head. The code that I've set up for this example uses a dummy head so that we can be guaranteed never to dereference a null pointer. And that's the goal. That's the goal of a circular linked list, is never to dereference a null pointer. So let's take a look at the code here. So I've set up my node struct inside of a separate header file right there, and it's just very simple. The struct can contain a single number and the node pointer. So the node struct can point to another node. A common name for this is next, but if you prefer, you can also use the other common name, which is link. So link and next are basically the same thing. Those are just two common ways of referring to it. The standard linked list has a constructor, an add to front, and then a print for traversal. So we can demonstrate traversal with print right there. The circular linked list is almost identical, so except the name is just different. We have the constructor, add to front, and print for the circular linked list. Let's take a look at the implementation file for the regular linked list, and you can see that the constructor sets head equal to null pointer. That's just like the picture we have. Head equals null pointer right there. And then if we want to add a new node, we set up our temporary node pointer, and then we set temp number equals the formal parameter right there. And then temp next equals null pointer. Okay, and then we check, is the head equal to null pointer? If so, then head equals temp. So we're having to check to see if we are dealing with a null pointer right there. And we have to check to see if head equals null pointer, etc. So this can be a dangerous thing to do. Whenever we dereference a pointer, if it's set to null, then we would be dereferencing a null pointer, and that would crash our program. Let's take a look at print right here. This is for traversal, and basically we're asking while current is not equal to null pointer. And we're just going to continue down the linked list with that statement right there on line 30. Current equals current next. So this is traversal, and we're just going to keep moving down the linked list until we find a next pointer that is set to null pointer, and that will stop the while loop right there. Okay, so with a regular linked list, if we're traversing, we would move to the head node, we would output the value, and then while next is not equal to null pointer, move to the next node, output the value if it's print, and then we finally reach the last node, we output the value, and then we say current equals current next. So now current is equal to the null pointer, and the loop stops. Let's compare that to the circular linked list version. And in the circular linked list, we're basically going to stop when current is equal to head. So we know that we've gone back around to the beginning of the list when current is equal to head. So node pointer current equals head next. We don't want to set current equal to head because that's the dummy node and there's no data inside of the dummy head, right? So while current is not equal to head, we keep moving down the linked list just like we did with a standard linked list with current equals current next. We stop the loop when current is equal to head. So with the circular linked list, we would skip over the dummy head. So current equals head next. So now current is pointing to 3. We would output 3. Then we would move to 5 and output 5. Current equals current next. Output the 7. And then current next right there is equal to head, right? So we're comparing this next member, or this next field right there, to the head field, and they're both pointing to the same place, so we know we should stop traversing our linked list. So that's how we can traverse a circular linked list. We just check to see if current is equal to head. So when current is equal to head, the while loop will stop. Okay, if you take a look at the code for the circular linked list, you'll notice that we never have a null pointer. So there's no way that we can dereference a null pointer. If we do dereference a null pointer, then that could crash our program. So let's take a look at a silly example. Let's ask if head is equal to null pointer, and then if head is equal to null pointer, if we do something like head number equals 3 or something like that, this will crash our program because we are dereferencing a null pointer. Okay, so that can never happen in a circular linked list because head will never be set to null pointer, right? In the constructor, we set up our dummy head. So let's take a look at the constructor for the circular linked list. The constructor is right here, and so the first thing we do is we say head equals new node. So now head has a dummy node, and then I just set the number for the dummy node equal to 0. And then we said head next equals head. So we have this situation right here. Head equals new node, head next equals head. So that is an empty circular linked list, and there are no null pointers there. So we'll never dereference a null pointer. Okay, and then we already discussed add to front, and then we just discussed traversal right there. Even though we're guaranteed never to dereference a null pointer with a circular linked list, there's still the possibility that we could dereference a dangling pointer. So for example, if we made a silly mistake like saying something like delete head or something like that, so head, we're dereferencing head right here, but we're dereferencing it after it's been deleted. So head would be considered a dangling pointer. Head is still pointing to the memory that was allocated by the operating system. So we might get away with it, and we might not. So this program might, like 99 times out of 100, it would run correctly, but then on that one time, it would crash the program. So there's no guarantee that we won't have a dangling pointer with a circular linked list, but at least we can make sure that we never dereference a null pointer, and that's what a circular linked list is for. That's why we went to all the trouble of creating that dummy head, so that we never have any pointers that are set to null. Okay, and so let's take a look at the main function. This is just a simple driver program. List 1 is a regular linked list. List 2 is our circular linked list, and I'm just basically adding the same numbers to both, and then I'm printing both linked lists. So list 1, the regular linked list, is going to stop when we reach a null pointer. List 2 is going to stop printing when the next pointer points back to the head. Okay, let's just run that real quick just to see the example output. Should show up there anytime now. Okay, there it is. So 3, 5, and 7, 3, 5, and 7. So this one stopped when we reached a null pointer, and this one stopped when we reached the head pointer. Okay, that's about it for circular linked lists. Thanks for watching.